So continuing on with Unit 2, at one point we covered all sorts of different types of equipment. Some of them we've used a lot more than others, like beakers, which I just spelt wrong, clamps, another type of clamp. We have a little crucible here, some tongs. Here would be a burette, a funnel, oops, spelled with two N's, a graduated cylinder, a test tube. Let's see, what do we have? A volumetric flask, or this one could be a volumetric flask too. It's probably better, it's labeled. Just a little squirt bottle down here. We used those a couple times. A mortar and pestle. And we have a Bunsen burner, which I don't like to use because you know I don't trust you guys in fire. And forceps, also known as tweezers to the rest of us, and scrapers and racks and stands and Erlenmeyer flask. Anyway, we've used all sorts of these as the years progressed. So what would we use to crush a powder into a solid? That's what we'd use this mortar and pestle for. So CC, mortar and pestle. If we want to pour liquid from one container into another, it would probably be a very good idea to use the funnel. If we're going to transfer very, very small amounts of material, that's when we might want this pipette. I know it looks like an eyedropper, but we call them pipettes in chemistry, so pipette. If we want to measure volumes of liquid, well, we could use a volumetric flask, and we might use those for making solutions. The best answer is usually the graduated cylinder. So let's go with M, graduated cylinder. Conducting a titration. Now, we demonstrated that, but we didn't actually do that. We will be doing labs like that after the SOLs. But that's when we use this burette that releases a very set amount of whatever we're using for a titrant into our analynt, the thing we're looking for during a titration when we talked about acids and bases. So that's when we're going to use O, burette. Sometimes they spell it with two T's and an E, but that's fine. All right, so here's a couple things I don't know that we really covered. So an MSDS means a material safety data sheet. And they may show you an example of a material safety data sheet on your SOL. And what that covers is all the important safety information, hazards, handling instructions for a given chemical. All that is contained in a material safety data sheet. If you are having a job where you work with hazardous chemicals, they would give you a material safety data sheet for every chemical you worked with, and you could use that. All right. So a fume hood. I don't have fume hoods in my classroom, but you may have seen them over in one of the other science classrooms if you've ever used Miss Lowe's room or Mr. Stietzel's room. That's why I don't store the chemicals here. So what a fume hood is, it's a enclosed and vented cabinet. And you can actually work in them with the doors half closed down, and they're usually glass doors so you can see. And its job is to remove toxic fumes from the area. And so if you have some chemical that you're storing that gives off a lot of gas, you know, it's a beaker and it's got a very low vapor pressure, so it's giving off a lot of gas. Remember, low vapor pressure means that it evaporates fairly easily. then you want to put it in a fume hood. All right, so let's look at some symbols that we might need to see. Symbols for things like flammable or corrosive. So usually what you're going to see for a flammable chemical, you're going to see some fire picture, and it may be in a red diamond like that. It could be explosive, but so anyway, it's got a picture of fire. A caustic chemical may have, well, actually, let's go on. We'll do corrosive first. So corrosive chemical, like what would be corrosive? Do you guys remember acids are corrosive? So you could see something, sometimes it's a little test tube symbol with it dropping on your hand or a piece of, and it shows like steam burns coming off. Radioactive, you probably have seen those before. They're the triangle symbols. I'm going to go ahead and let's see, what are they going to give us for caustic? I'm looking one up. Sometimes they'll just say caustic, and often the caustic chemical and the corrosive chemical are going to be very similar. You might see a hand. That is a hand. I know it doesn't look like one. With something dropping on it, and it'd say danger, caustic. And let's see, I'm going to pull up the radioactive just to make sure I write it right. And that would often be the circle with the, what do we got? 3 black triangles and 3 yellow triangles. There's other symbols for biohazards, which we don't need to worry about, but just in general, all these symbols mean something about the hazards of the chemicals. And if you looked at the storage facility over by Mr. Stiesler's room where we store all of our stock, the stock that fits these are going to be stored in the appropriate cabinets and are going to be stored with the appropriate labels. And, you know, think about it, storing chemicals. If you stored stuff alphabetically, you may be putting things together that are very reactive. So we don't want to store them alphabetically. We want to put the acids together because acids don't really react much with other acids. And we want to put the bases together because they don't really react very much with other bases. But we definitely don't want to put the acids and the bases together because they are very reactive. All right, PPE is an abbreviation that you might see, and it stands for Personal Protective Equipment. And since I happen to be a big fan of green chemistry, we don't do a lot of stuff that we really need a lot of PPE, but we have used some PPE, things like goggles. If you were doing something really dangerous, you could use a face shield, you know, closed-toed shoes, gloves, aprons. All those things would be a parts of personal protective equipment. Okay. All right, next bit is for you to do on your own as many lab safety precautions as you can. That could include things like no horseplay. It could include things like, you know, wearing the right PPE. It definitely includes things like listening to the instructions and making sure you follow all the instructions in the lab. All right, so still in Unit 2. Now we are going to switch and talk about accuracy and precision. This comes up a lot. Accuracy is closeness to true value. And that's when we can calculate, value. That's when we can calculate something called a percent error, how far off we are. Your test scores are a percent error, how close you got to my key. Precision often has to do with how tightly grouped your data is, or how big your range is. But it could also be things like how small measurements can be. How much difference can you get in your measurements. For example, if I'm using a graduated cylinder that's marked to the nearest ones place, I am less precise than if I am using one marked to the point ones place. And so for precision, we might talk about percent uncertainty. So two very different things. Uncertainty goes with precision, which has to do with how closely we know a value. And accuracy goes with percent error, and that's just how correct we are. And we're going to do some practice with finding percent error. That comes up on every SOL. So if you haven't done so yet, you probably should review percent error.